Hello everyone, I'm Arid,
I'm Rachel.
I'm Hamza.
And I am Anjana.
and we're Team 16. Let's begin by revisiting the original aims of our project. This study explored how two common input methods, tap to text and swipe to text, perform in scenarios where visual feedback is limited or completely removed. Our key objectives were evaluating how effectively each method works under three visibility conditions: full visibility, partial visibility, and no visibility at all, and determine if one method is better than the other for everyday multitasking situations. We also wanted to assess performance based off typing speed, error rate, learnability, and ease of use to see how users adapted to each method. This project began as a replication and modernization of a study from 2005 that explored limited visual feedback that affected mobile text entry. The original study focused on input devices like the Twiddler and mini QWERTY keyboards, which were early mobile text entry tools. So they focus on which device performs better when users can't rely on looking at the screen. So in terms of study design, we recruited 10 participants, each who tested both input methods, tap and swipe, under all three visibility conditions.
As with the most real-world studies, a few things evolved from our original plan and also from our original study we set out to replicate. As for the changes from our original test design, we disabled autocorrect to avoid assistance from the device. We also enabled screen recording for more accurate post-test analysis. Although we originally planned for one-handed typing, we allowed two-handed typing for user comfort and realism. We disabled backspace, again to capture unedited performance. And finally, we made a shift in how we measured errors based on entire words rather than individual letters. These changes were driven by what we learned during our pilot testing. And these changes helped improve the reliability and richness of our final data. Here's a breakdown of how we structured the testing phase. We had 10 participants, each completing a total of 18 test sets. These were randomized per participant to reduce order effects and bias. Each participant went through 3 rounds with 6 tests per round, covering all combinations of input method and visibility condition. Each session took about 10 minutes, totaling approximately 1 hour of testing per participant, including warm-ups and breaks for reducing fatigue. In addition to collecting speed and error data, we also gathered qualitative feedback after each round using NASA TLX, a trusted scale that measured perceived effort, frustration, mental demand, and satisfaction. This mix of objective and subjective data helped us understand not just how people performed, but how they felt while performing the tests.
Before diving into the results, let's take a quick look at a live example of how our participants interacted with the two input methods. So as you can see on the left, we have our full visibility type to text test method. In the middle video is our partial visibility tap to text text method. And then on the right-hand side is the no visibility tap to text experiment conditions. Now let's look at what we found. Starting with speed, we saw that tap to text consistently outperformed swipe to text in all conditions. Speed dropped for both methods by around 15 to 20% on average when vision was impaired. Moving on to accuracy, this is where swipe to text showed some potential for being a good text entry method for situations with limited visual feedback. The accuracy of swipe to text with partial visibility was 75% compared to the 70% of tap to text. Tap to text didn't show much improvement across rounds in terms of learnability, but swipe to text did show a little bit of improvement across the rounds, which led us to believe that people were maybe not as familiar with swipe to text initially in the experiment. And so over time, they improved their performance. And then finally, in terms of ease of use, participants found that tap to text was less demanding and perceived their performance to be better when using tap to text over swipe to text. These results helped us understand not just how each method performed technically, but also how users experienced each one during the tests. Here are some of the graphs of the data that we generated. Across the top, you can see the tap to text and swipe to text for our speed. And on the bottom, you can see the tap to text and swipe to text for accuracy.
To wrap up, here are some of our key reflections and conclusions from this project. What worked well was our structured within subjects test design. It allowed us to make fair comparisons across all conditions and input methods. We also benefited from capturing both quantitative metrics like speed and accuracy and qualitative insights through NASA TLX surveys. This gave us a much more complete picture of user experience. Of course, we faced some challenges. Participant fatigue was a real issue. 18 test sets per person is a lot, even with breaks. And it was surprisingly tricky to consistently block parts of the screen across participants, especially in limited vision conditions. Looking back, there are a few things we'd do differently next time. Automating data collection would save time and reduce human error during analysis. We'd also aim for a larger and more diverse sample size to improve generalizability. Our key takeaways are that each input method has its own strengths depending on the visibility context. Users show different learning curves, especially with swipe input. And most importantly, how users feel about a method doesn't always align with their actual performance. These insights don't just validate our findings, they also point towards how mobile interfaces can be better designed for real-world, eyes-off scenarios. Thank you.